Okay, so it's part 2 of lesson 6. We've kind of introduced the concept of loops, and now we're going to actually try and build some of this stuff. So let's open up Visual Studio. And we'll create a new project for today. I'm going to create a new project. Make sure your language selection is set to C#, not Visual Basic. As usual, we're going to do C# and a Windows form this app. So I'm going to call my project week 6. And we'll get our blank form. I'm just going to go into my directory for a minute. Now you'll notice what Visual Studio creates, and I had a number of issues with this, with assignment 1 submissions, that many people went into there. So here's our solution file. So double clicking that opens the whole solution in Visual Studio. So that has this .sln extension. And then inside it creates a subfolder with the same name as my project. Now many people on their assignment, all they did was give me the form and the flowchart. If I just have your form, I can't actually run your code. So I need all of this. Any projects, what you need to do is go to the root folder where you'll see 2 things, the .sln file, the Visual Studio solution, as well as the project subfolder. So when you're submitting, I need all of this stuff. So when you zip it up, it should create a zip file that has the solution as well as your entire project and all the support libraries. Otherwise, I can look at your code, but I can't actually see the form and I can't run it. So for all future submissions, make sure you please give me the entire thing and not just the form files, or I can't actually mark it. So I did my best to mark the ones I got, but in future, I need everything, please. Okay.
Just a quick question. When you have that website up about the music collection,
yep.
You click into a record.
Yep.
This becomes, how do you open something like this on Visual Studio where it's not like a pop-up box like this, but it's like part of the page?
Well, see, right now, just for simplicity, we're not actually working with web applications, right? These are just desktop applications. And the reason we're doing it in this course is we're kind of removing all the HTML, CSS, so we can just drag and drop our interfaces so it's simple. So in this course, we're using Visual Studio, but when I create a new project, rather than using a Windows Forms template, just open another instance. So in this course, we're just using Windows Forms for simplicity, just to learn. What we'll be doing in our server-side scripting class when we create a new project, instead of Windows Classic Desktop, we'll be picking web. So when we pick web application, we then can either get an empty one or we'll be using this, which provides a template, so it pre-builds a whole lot of stuff for us. Like it builds a header, it builds a register and login page. So we'll be using this template later. So if we're building websites, we pick web application. We're not doing that yet.
All the code is the same.
Yeah, all the C# code is the same, right? We can see that here. So this is just similar C# code. There's no HTML here. This is all our logic. And then we have separate files here that will contain, so here's the page to, for example, the page that shows all the albums. Here's all the HTML. It looks like this. So we've got a table and probably somewhere in here, here's one of our loop structures. For every album, go ahead and make a new row in the table. So that's how we'll apply the concepts we're doing in here with Windows Forms, and then we'll move it to the web next semester and then again in semester 3 and 4 with some different technologies. So we'll try a basic loop here. So to do this, let's drag on, as usual, a label, text box, and a button. Actually, I'll put on my text box first. So here's what we want to happen when we run this. Now, nothing's going to happen. What we want to do is enter a number, and then we want to use a loop. Whatever number we add, so let's say we enter 10. We want to click our button, and we want to use a loop to start at that number and count from that number up to 20, and then we're going to stop. And we'll display those results here. So if I type in 19, my label should say 19, 20. If I type 10, it should say 10, 11, 12. So we know exactly where we're going to stop. We're going to keep adding that value to itself and displaying those numbers until we hit 20, and then we stop. So I'll maybe just change the text on this that says, I don't know, up to 20. And then I'll double click it, so Visual Studio will write the click method and we can put our looping code in there. I'm not going to change the names of anything because they're not very descriptive in this case anyway. So here's what we want to do. Whoops, one more thing. Label 1, I'll take the text off of here. So my label is blank. For starters.
What did you mean by that?
I just left it. It's label 1. So we'll do our pseudo code here. So the first thing we want to do is get the user input and store in a variable. This part should start to be seeming familiar. We've done it over and over again. Give the user a text box, grab what they gave us. We're going to convert it to a number and save it. So that'll be step 1. Two is as long current value is less 20, add this value to the label. So long as our current value is less than 20, we're going to add the current value to the label. And then we're going to add 1 each time we go around. User enters 15, we want to display numbers from 15 to 20. They enter 1, we want to display the numbers from 1 to 20. So the first part you should be able to do, nothing new there. Create an integer variable, give it a name, and populate it from the text property of our text box 1. Whatever the user enters, we're going to consider that our start number. So in this case, we don't know how many times our loop is going to go around, right? If the user enters 19, our loop is only going to go around. It only takes one cycle or one iteration to get to 20. If the user enters 10, our loop is going to need to go around 10 times. It's going to take us 10 times of adding one number till we get to 20 and we can stop. So the structure we use for this is called a while loop. So it would look like this. While so long as our number is less than 20, we want this loop to keep going. We'll just do it this way for now. So as we go around, print out the current number, but add it on to whatever's already in the label. That's what the plus equals means. So if the label already says 10, add an 11 beside it. When it goes around again, add a 12 beside that. We're not replacing the value. We're just adding on to the end each time. Now we could run the code like this. But if we run it like this and click the button, our program will never end. Watch what happens. So I'm going to enter number 10. So nothing ever seems to happen because the one danger when we create loops is what's called an infinite loop. Just stop it. Let's just watch what happens here. I'll start it again. Put in the number 10. It's checking start number. So this condition is true, right? My start number is less than or equal to 20. So my code goes in here. And now my label says 10. So now we come around again. What's my start number? It's still 10. So now my label says 1010. This loop will never end the way we've coded this, because that condition is always going to be true. So we need to do one more thing. After we print 10 the first time, what do we need to do with this value after we display it on the label? Stuart?
Maybe display the value?
Well, that's what we are going to display the value. Well, we don't want to stop it. Right. Once we've printed out 10, we now need to change the value of start number by adding one more to it. Otherwise, it just stays in the same place. It's like a hamster on the wheel, running and never going anywhere. So after we display the first number, we want to move to the next number. Display that, and then we'll keep going until we hit 21. Right? That was our last instruction. Add 1 to the current value. But take the current value of start number and add 1 to it. So print 10, and now our start number is 11. So let's try it this way and see if our loop actually ends. So we should get, hopefully we get the numbers from 10 to 20, or 5 to 20, or 15 to 20, whatever value we enter. It should keep going so long as we're at or less than 20. Stuart?
What's the difference between 2 pluses and the plus and equal?
Okay, good question. If we just do this, they're equivalent. Two pluses means take the current value and add 1. So they're equivalent. Plus plus always means just add 1. Maybe we want to count in increments of 10 instead of increments of 20. So let's try it now. Okay, our output's a little hard to read, but this is the right result. We might want to add a comma or a space after each number so that it's a little easier to read. So maybe after we print out the current number, we'll just add a space. So those numbers don't all run together. So we should try this out with some different numbers and make sure it works regardless of what number the user types in. Let's try it with 10, and then we'll try some other figures. So 10 seems to work. Okay, well, this sort of worked. Here I went from 10 to 20. Then it goes from 16 to 20. So what we probably want to do every time the button is clicked, we probably should clear off any text that's on the label. Otherwise, it just keeps adding forever and ever. So we should probably reset the text each time the user clicks the button. And that way we're starting from here. So we don't know how many times our loop is going to run. We just know when we want to stop. We want to reset the text on the display label. So whatever value was there before, let's get rid of it before we start counting again. So the label actually has a built-in method called reset text. Whatever was currently on the label gets cleared out. We could also just set the text property equal to an empty string, 2 quotes. That would also get rid of anything that was printed on the label. So let's try it this way. We enter 10. We go from 10 to 20. We start at 20. It goes around 1 time. Add 1, then we're at 21, so it stops. So we'll never get a value above 20. If I start at 100, this never happens. Because right from the beginning, our start number is never less than 20, so nothing inside of here happens.
How can you, what would you have to change in order to have it look at the value input, say 10, and only display the numbers between up to 20, so like 11?
So if we started at 10,
but you don't want it to include 10.
Okay. All right, great question. We could easily do that. So if the user enters 10, what Brandon's saying is don't display 10 because we've already got 10 here, right? So you want the first number to be 11.
Yeah.
If they enter 15, the first number in our label should be 16. Okay, so what would we have to change here? Nothing in our loop, actually. Shiva?
Swapping that start number plus equal to 1 to opposite.
Yeah, okay. So here, before we start our loop, like we've got the number they typed in, we could just add 1 to it first. So if they type 15, we want to start at the next number. They give us 15, we're going to start our loop at 16. They give us 3, we're going to add 1 first and then start looping. So that should give us the result you're talking about. They give us 4, start at 5. They give us 14, start at 15. Now, in this case, we've also chosen to count by 1s. We could count by 2s if we wanted to. So we have full control over what that loop looks like. We'll try another example. So in this case, we use a while loop because we don't know how many times it's going to go around. We only know what the condition is when we want to stop, which is 20 is our max. So this loop, depending on what input we get from the user, the loop might go around once, it might go around 20 times, might go around 0 times, or any number in between, we don't know. Sometimes we do actually know we want to execute a specified number of times exactly. This is probably your most classic example, right? The dice tell us exactly how many times we need to do something. For example, how many spaces to move on a board, or how many cards to pick up out of the deck based on this, right? I'm going to move a space in a loop, move ahead, move ahead, move ahead until I've gone however many times the dice have told me to go. So for this one, we use kind of a different style of loop. So we'll add another little section. Rather than a text box here, let's put on a combo box. I am going to give this one a name just so it's a bit descriptive. We'll call this CBO month. So there's 2 ways. Imagine we're building a checkout page or a credit card payment page, right? Pretty much whenever we're going to have one of these, that kind of page, we need the user to pick the month of their credit card. Now, we could type in all of the values, but that's really not necessary. We could use a loop to fill our combo box instead. In this case, we know how many times, how many possibilities, how many items are we always going to have in this list. It's probably never going to change. If it's for the user to choose the expiry month.
So that's a combo box, not a text box?
Right. So it's got this little arrow user can click. How many options should be in this list? Yeah, we know it's always going to be 12. Right? We're not going to build a expiry month box with 3 options. So we can use a loop. In this case, we know we need 12 options. So we could type them all in here from 1 to 12, or we could use a loop to automatically fill those options. And this one we'll do it up here. The user doesn't need to click a button. As soon as the form loads, we want to fill 12 months of the year into that drop-down list. So if I go back to my form, I can just double-click the form, and Visual Studio writes a form load method. Anything that should happen as soon as the page gets loaded. Sorry, if you missed that, just select your form. You can just click anywhere in the blank space, and it should say form here, and then double click, and it'll generate a form load.
Sorry, did you do anything else besides change the name?
Nope.
Okay.
All I did was drag the combo box on and call it CBO month. I gave it a name because after that, we want a year box beside it. We'll do the months, and then we'll build maybe a year box where it lists the current year and the next 10 years. But we want these would be preloaded as soon as you got to a payment page. So we're going to do it as soon as our form loads. We'll automatically populate those lists. So a for loop is when we know how many times we want to go around. In this case, we know it's 12 times. But here's the structure. We create a variable that describes what we're looping for. And usually it's going to be an integer because we're going to loop from 1 to 12. So this is where we're starting. We're starting at 1. The next condition is, how do we know when to stop? Or sorry, how do we know whether to keep going? In this case, when month is less or equal to 12, that's the condition that tells us whether our loop should go around again. So long as our month value is less than or equal to 12, we want to repeat this process. Once month, we'll stop because we don't have 13 months of the year, at least not on this planet. And then the last piece of information is, as we go around in the loop, how do we want the month value to change? In this case, we want to add 1. That's the most common. If we start at month 1, the next time around we want month to be 2. So to add 1 at a time, we can use, Stuart, as you suggest, that's commonly where you see plus plus. Take the current value of the month, and next time around, just add 1 more to it.
How do you know when to use a while loop different than a for loop? Like, how are you supposed to know which one to use?
Well, typically we use a for loop when we already know how many cycles or iterations, how many times we need to go around. With months, we know there are 12, right? So we would use a for loop because we know what number we're starting at and what number we're finishing at. We might use a while loop when we want to say display a whole bunch of data, like a Facebook friend list, but the size of that list is going to vary. So in that case, we'll say we would go until while there is still items in the list, and stop when there's no more items. But we don't know the number of items in that case.
Did you use a loop for the same process that we're doing right now except with the words? So like spelling out January rather than 01.
Yeah, we'll try that after. We'll get it to run with the number, and then we may be able to get it to show the word. So in this case, we're going to start at 1, we're going to count to 12, and for each value, we want to add that value to our month dropdown. CBO month. It has a list of items that we're going to add current month. So start at 1, add the numbers from 1 to 12. Each one is a new item in the list. We may have to tweak this a little bit. We'll try it. We'll see what happens when we run it. So our list automatically populates with the numbers 1 to 12. So this is more efficient than us typing those 12 options in the list. we can use a loop to fill it. Now, Matt, you had a good question. Let me think about how we might get. Check. I got to think about the most efficient way to do this. Google's my friend. Actually, DuckDuckGo is my friend because it doesn't track me like Google does and try to sell me stuff based on what I search, which annoys me. We could. We'll come to that. I should point this out. Notice where all the search results come from. We had twice a year, we have a program advisory committee meeting where we invite business owners who, many of which hire our students on co-op and grads to come to the college. We feed them pizza and coffee and we say to them, what's going on in industry? What are you seeing from the students we hire? What things should they need to know? And it was funny because one of them actually said the other day, one thing you should make sure all your students know is how to use Stack Overflow, because that is the #1 place to go when you need an answer and you're doing research. Okay, so let's see. Best way to turn an integer into a month name. Okay, we can try that. Date, time, format info, current info, month names. And we could use that number. We could try that and see. I'm not sure. Okay, so this is a built-in method in Visual Studio, but it's not recognizing it. We get that red underline. It says this isn't going to work. However, we get this little light bulb here that suggests how we can get it to work. It says, if we just reference this code library, then that function should get, that method should get recognized. Hang on. Get month name. There. I think, Matt, that should give you the names. So this is a library that comes with Visual Studio, and it has a method. Going back to your earlier question, we're calling a method called getMonthName, and it has an input parameter of the number. You pass it the number, and it gives you a string back, which is the name of the month.
I'm still getting the red underline.
Okay. When I clicked that, what it did.
Okay, it's good now. I didn't realize you have to actually plug it. Sorry.
Yeah, you have to click it.
Okay.
And now it gives us the names of the months instead. Yes, you choose that using system globalization. So what that does, it adds this line of code up to the top. That's a code library that comes with Visual Studio, and it contains this public method that we can call from any page to send it the number of a month, and it will return the proper name. So we're calling that method 12 times in a loop. So if we watch and see how this actually runs, so it starts at 1. My month is 1. When it calls that method, it now adds January. And then it says it's month. So month is now 2, and it loops around 12 times. and it adds those items one at a time.
How do you go into that view to see what it's doing?
First thing you have to do is you have to put a breakpoint in. So you click in the little gray bar over on the side, wherever you want to start watching the code. That's called a breakpoint. And then you run your application, and as soon as that part in the code gets hit, it automatically jumps you into this window. So we don't see the form anymore, we see our code. And we move through it one line at a time with the F11 key. Every time you press 11, it goes to the next line. So you can watch what's happening. So when month is 1, I've got one item in the list, and that item says January. When my month is 2, now I've got January and February. So that list of items is populated one at a time. Goes around 12 times. Melissa?
Saying that they count time converted as not counting added feature for code.
Do you have that reference at the top enabled? System.globalization?
Should I close?
Yes, you need that reference. Without that reference, it doesn't know where to find the method called get month name. It's in that library that we've included.
You want to just on the code view, is there a way to wrap the text so that you don't have to keep scrolling side to side to see longer lines?
It should be somewhere in the options, I think. Under tools and options. Maybe under text editor. Where did you find it?
So go to text editor.
Yep.
And then under C#, and then there's a little box inside. Yeah.
Enable word wrap. Yeah,
Yeah.
so it'll wrap those onto one line.
And then I do know that visual voice will show like a weird P thing to show like the line breaks.
Right.
So we don't want that.
Yep. So we don't have to show the names of the months. It's simpler just to show the numbers. If you're having a problem with that, that's okay. But that's how we would do it. So we want to add a year box beside it. And we want to take the current year and then display the current year and the next 9 years after that as the credit card expiry year. We don't want years in the past. We don't want credit cards that have expired. So let's grab another combo box and put it beside and call this one CBO year. We've got a month and we've got a year. And then we can go back. We're going to add that second loop right inside of form load. First, fill the 12 months, and then fill the next 10 years, starting with this year. Now, we could start our loop at 2017 if we wanted to, and then loop 9 more times to display. But the problem is, as soon as it's January 1st, we're going to have to go back into our code and change the start year all the time. So it would be better to actually, if Visual Studio could automatically give us the current year as the starting place, that's probably better. So that way we don't have to update our code every year. So first, let's get the current year. So this will always give us the current calendar year. So if we run this same program again in January, it will start at 2018 rather than starting at 2017. Actually, whoops. I'm going to just change this to start here. So we're going to start at the current year, and we're going to loop so long as our value is not more than 10 years from the start. And we're going to add one each time. So in this case, we're going to loop starting at 2017, and we'll go to 2027. Same code in January will automatically run from 2018 to 2028. And then each time we go around, we're going to add the year to our year drop-down list. Just see if this works the way we want it to. So there are our months. And here are our years. So we've never specified from 2017 to 2027. We've just let Visual Studio figure out the current year and then loop around 10 more times. So our for loop structure is always the same. What number are we starting at? What number are we ending at? And how much are we incrementing by each time? We make a note here that plus plus means add one to the current value. So we know in each case how many times we're going around or what value we're stopping at.
So for my CBO year at the very end, I have a line.
Okay, and what does it say?
The name CBO year does not exist in the current.
So that means on your form, you probably haven't changed the name of that second drop down. Or if you did change it, it says something other than CBO year. Or you haven't created the second drop down. So you're trying to refer to an object that doesn't exist, right? It's like me trying to talk to somebody in this room named Hector. I can call Hector all I want. I'm not going to get a response because there's no Hector. You're calling something that doesn't exist. That should fix your problem. So in both of these cases, we've counted by one. Want to look at an example, do one more example where we use a for loop, but instead of counting by one, each time we count by something else. But whenever we build pages with a credit card box, we're going to use loops like these to populate those. We don't want to have to type in all those values and then change them every year to get rid of the previous year. We'll just use loops to fill the options. And this way they're always going to be up to date. Okay. Let's drag on maybe one more label. and button. So what we want to do here is when the user clicks the button, we want to display all of the years where there's been a Summer Olympic Games. So the Olympic Games started, the modern Olympic Games started, I think, in 1896. And every 4 years, we have the Summer Olympics again. So we're going to loop starting from 1896 until the current year. But instead of showing every year, we're only going to show every 4 years because the Olympics only happen on that cycle of every 4 years. So I'll just rename these. I'll rename my button, just so this is a bit more descriptive. I'll rename it Button Olympics, and I'll rename the label the same, LBL Olympics. And I'll just take the text off my label, so when the form loads, it doesn't say anything. My label will kind of disappear. And maybe I'll put some text on the buttons. Oops, that says get Olympic years. So we don't know exactly how many times this is going to run. We just know our loop is going to start at 1896. We know we'll want it to end at the current year, and we'll want to add 4 and display that value each time. So let's double click it. Well, you know what? We can actually, let's do it as a for loop first. And this is a scenario we could actually use either one of them. So if you want a challenge, try and write it as a while loop. I'm going to do an example with a for. Okay. So we'll say, again, we're dealing with a number. So that's where we're going to start, is 1896. We're going to stop at the current year. So we could hard code in 2017, or again, we could just use this function to automatically generate the current year. Start 1896 and stop at whatever the current calendar year is. Now for these other loops, we've used plus plus because we've added 1 each time, right? We went from 1 to 12, and then we went from 2017 to 2027. In this case, we're not going to use plus plus because we're not counting by 1. In this case, we want to say plus equals 4. So take the current year and add 4 to it the next time around. We're going to loop. Oh, yeah, probably is better if I do. No. We're incrementing by 4 each time. We're going to take, again, just like we did with our first, we're going to print all of the years on that one label. So we'll use, whoops, plus equals. And then we'll add a space on. Each time we print a new Olympic year, we'll add a space on the end of it. So then we could separate it from the next year. Now in all of these cases, we're also counting up. We're starting at a lower number, and we're adding on and we're going up each time. We don't have to do plus plus. We could do minus, minus, minus. If we want to start at a higher number and count down, no problem. We could do that too. If we want something in a descending order, from a higher number down to a lower number, we can go backwards. For example, we might see that if we were looking at building something that we're calculating, say, how long would it take you to pay off your mortgage? Right? We're going to start at this amount, and as we make payments, it would show us how much we still owe until we get to the bottom. Let's try this one out, see what happens. So those are all of the years. Instead of going up by 1 each time, our values go up by 4 every time. So we can see which is accurate. The last Olympics were last summer. And again, there'll be no Olympics next year, not again until 2020. So we have control to display, to go through our processes. Most of the time we go up by 1, but not always. So here would be an example of where going up by 1 doesn't make any sense because the Olympics don't happen every year. They only happen every 4th year. Stuart?
How would you structure it?
Okay, good question. We can try it that way. Maybe what I'll do is just copy that section down below. So I'll rename my button. So this one will be Olympics while. And the label will be Olympics while. So we'll try and repeat the logic with a while loop. So I can double click that. So Stuart, I'll throw it out to you. How do you think we would do this?
Maybe while the date is 27. While the date is whatever date you're looking for, so it'd be like 1986, right? So I go, while the Olympic year is 1896, and display everything after that.
Okay, yeah, you're on the right track. Anybody may want to? Okay. So first we want to set out a start value. We're going to start at 1896. That was the first year. What would our while condition look like? Keep going so long as Olympic year is, Joel? Right. So keep going. Well, so long as this condition is true, as long as the Olympic year is less than this year, keep going.
You added another for the.
Yes. So I added another label, and so we're going to do 2 versions, one with the for loop and one with a while loop. So long as this value is less than or equal to the current value, keep going. So we're doing the same thing, we're just printing it on our second label. If we run it like this, though, we're stuck in an endless loop. So what do we need to do to make sure each time we go around, what do we need to do with this value after we print it? Right, we need to take the current value and add 4 to it. So these are now equivalent. They should run exactly the same way. So start at 1896, check if the value is less than the current year. If it is, display it, and then add 4. And keep going until this condition is no longer true, and then stop. So if we try this second version, it should, if we click both buttons, we should get the exact same output. Let's see. So those are equivalent. Stuart?
Does it matter which order you which order you put the plus minus 4 in? Like if you put the Olympic year above that displaying the label, would that change the program or does it not matter?
Well, so if we start at 1896, so you're saying if I move that up here?
Yeah.
Let's try it. What do you think? Do you think it will be the same or will it be different?
I think it'll be different. I'll change like the value of the Olympic year because it's adding 4 to Olympic year before you display it.
Let's see. So hardly different.
It added 4 before it
Mm-hmm.
told you what the current year was.
Right. So we don't want to do this until we've displayed the current year. We want to display the current Olympic year, and once that's done, then we need to go to the next one. So this, it works, but now we skipped the first year because you're already jumping to the second year before you ever displayed the first value. So while it doesn't throw an error and it gives us almost the right result, it's not completely accurate. We want to display the current value first before we increment on and go to the next one. So there isn't a right or isn't a wrong. If you gave this problem to 100 different programmers, probably 50 of them would use a for loop and 50 of them would use a while loop. There isn't really a right or a wrong or really a big performance benefit from doing one or over the other. Any of them would work. Okay?
So when exactly would you use a do while loop versus a while?
Functionally, those are they're basically the same thing. There's two versions of a while. We can either do it while a condition is true, so long as this is less than that, or we can have an until loop, basically. Do something until, but they're really functionally equivalent. Stuart? Okay. So we might do something a certain number of times. We might do something while a condition is true, until a condition becomes true. So that's kind of the opposite of the while loop. That's an until loop. So do something so long as a condition is false. So I'm going to give you a few more. There's a bunch more examples on Blackboard. We've done a few of these together. Let's go to what I'd like you to do with the remaining time, I don't expect you're going to be able to do all of these. Maybe the first 5, and if you don't finish them, you can finish them at home before next week's class. So just add on, you can make a new form or a new project, or you can just draw. We've got a big form, there's lots of room on here. So first one, use a for loop. Rather than going from up, I want you to go down. Start at 10 and count and display the numbers from 10 to 1. Then make a for loop that goes from 10 to 50, but goes up by 3 each time. Then go from 50 to 10, go backwards in steps of 7. So try the first 5. So you'll, for each one of them, basically, well, you don't, I guess, really need a text box. You just need a button and a label for each. So clicking the button, each button runs one of those loops. So do as many as you can just for practice. I'm going to stop the video stream. I'm happy to come help. If you get stuck, you have an error, just ask. And then before you go, I'm going to give you lab 3.